All right, so before we start with today's class, I took a look at your quiz, and I cannot resist the temptation of going back to your answers. Because question 1 was about filling those blanks, was all good and nice for the most part. But question 2, as soon as you are facing a little bit, nothing really special, it went completely, blew completely in all directions without any logic. So I'm giving you a production function, which is a very standard format, right? Capital, labor, and technology. You have seen that the production function I used in that example was the same as in Abel Bernanke. Capital was not there. And we had done it, with respect to that. So, and I remember asking you about if you are comfortable with taking derivative with respect to labor. So I assumed, while writing this question, that you are, since you gave me that answer, I assumed that you are familiar with that. So given that, I'm asking you to calculate the marginal productivity of labor here, which is basically nothing but the derivative of this function with respect to labor. And how do we calculate that? What is that equal to? 1 minus alpha. A. So this part has to be treated as a constant in this case, because this is a partial derivative, right? So we just rewrite it, and then n minus alpha, right? That's the correct part. Many people also, I noticed, stopped here. Then I'm asking you, so this is basically just, calculus. There isn't even much economics in it. Then I'm asking you to write down, based on this marginal productivity of labor, the labor demand equation. So how would you do that?
MPN is equals to wage.
Yeah, so W equals
MPN.
to the right-hand side of this, right? 1 minus alpha, A, K over N, alpha. That's the answer to that. Why very few people, so how complicated is this? How many people got this far? How comes I saw few quizzes, nobody was saying, so all the wrong people are not here, the right people are here now, don't get it. But anyway, this is, so once we get here, now I'm asking you to sketch on a suitable graph that labor demand equation. So I saw all kind of, graph with prices on one axis, this and that. What should the graph representing labor demand look like? What should we have on the vertical axis and the horizontal axis? The price of labor, which is the wage, okay? And here, quantity of labor employed. And then, of course, since you see this is in the denominator, what does that mean? It means that there is an inverse relation, right? So, it's not linear in this case, unlike the case we did from Abel Bernanke. That was linear, that was a line. This is not linear. So it's something like this, right? You are smiling because you...
Sorry, I did it wrong.
You did it wrong, I know.
Sir, I draw the line.
You drew the line.
Sir, I got the equation and then drew a linear curve.
Okay, but did you get the right things here?
Yes.
Yes, sir.
I did.
And
What about B part?
this part also, what did you do here? The equation of the labor demand equation, the equation equating wage and marginal product of
Yes,
labor.
sir. I did that.
What did we have to do in B part? Square it to W. Plus, yeah.
So since I covered this just now, I wished you came at 2:50 so that you would have listened to that. You also came late for the quiz, I noticed. So you are a late comer.
Just for great. No, we just had it during 30.
Anyway, we just computed the marginal product of labor by taking partial derivative, equated to wage, and then drew it. That's all.
And what if we do the graph right and not the equation?
But why you should not do the equation right? Are you?
I came with the right equation, but I didn't just equate it with W. Many equations came with that.
Another late comer here. A tendency to come late. I start remembering when people regularly, show up with those few minutes delay. So, question 2 was a mess for most of you, regardless of what you say now. I saw it in the quiz. It was a mess. And please stare at that. You should know. And don't, I mean, for some of you, it was actually not a mess. It was like good answer up to a point. And then sudden silence, and people, I saw they left 10 minutes early, so it was not a matter of lack of time. If they left 10 minutes early, they had plenty of time to complete the question. But they left it blank somehow. So please, this is the answer.
Sir, the equation for labor demand, and shouldn't it be in terms of n is equal to something?
Yeah, n star, we could have done
So why would it be equal to wage? I mean, why would it be in terms of
So you generally don't have, x, y equal f of x. Why you want to see x equal f of y?
No, sir, that's right for the graph, but what I'm just asking
So
about
this is w in terms of labor employed, n. It's just like y, w, equal f of x, which in this case is n. So it's w equal f of n. It's the same thing. N is here, just like you would have x, and y is here. Why you want to flip it over?
No, sir, I was just asking about the equation. Like, if we don't have to draw a graph, we just have to give the equation.
Even then, to derive the equation, all you have to do is to equate the wage
to the marginal product.
To the marginal product of labor. So that's what you get. Then you can always, enjoy and invert the equation by solving it for n, if you want. But that was a much further, algebraic step, which was not required at all. Okay, so being done with that, let's move on to today's class. So last time, remember, after talking about the real business cycle theory as an explanation for business cycles, we checked what were the good predictions of that theory, but we also said it is problematic in a couple of things. One was about unemployment. So we mentioned, remember, that unemployment cannot be easily accommodated in that theory because markets clear, and what we do observe unemployment, and that argument of mismatching frictions is not entirely convincing. You remember that argument, right? So today we are going to look at another problematic area for the same theory. So that is the neutrality of money. So according to classical macro theory, money is neutral because prices adjust immediately, a complete flexibility of prices, so money is neutral. However, in reality, it is observed that money is not neutral. So how do we explain that? So there is one explanation which is not entirely convincing, and we'll cover that, and then a more rigorous explanation which is known as the misperceptions theory, and we will cover that as well. And then finally, I will cover the algebraic version of the same, of that misperception theory. Okay? So, going into the issue itself, the classical theory claims that all markets, labor, goods, and financial, they all clear instantly. For this reason, if you have an increase in money supply, what should happen with complete price flexibility? The LM curve shifts, and then nothing of that happens. Since prices immediately respond, output just remains at the full employment level. And so we talk of money as being neutral, not having an effect on output, okay? Or any real side variable. But in the data, we see that money is a leading and pro-cyclical variable. What does that mean? Leading means we observe increases in money supply, and then, after a lag, we observe increases in income, increases in output. So it's a pro-cyclical variable. Leading because it happens before, and also in the same direction, so pro-cyclical. So, and the same happens in the other direction. If money supply, so we see that money supply goes down, and then after a bit, output also decreases. So how do you explain this if money is neutral? So one argument is reverse causation. What do we mean by reverse causation? So today you had a quiz, right? Let me give you an example. Today you had a quiz. So let's say, probably you didn't, but suppose you studied yesterday for the quiz today. So can you conclude from this that your studying yesterday was a cause of the quiz today? No, you would have had the quiz regardless, whether you study or not, you would have had your quiz. It went the other way around. You were actually studying because you would have a quiz. So that's reverse causation. You know, also yesterday there was some thunderstorms, some rain. So I saw people with umbrellas. So people took umbrellas. Did those umbrellas cause the rain, the thunderstorm? No. The thunderstorm caused people to take umbrellas. So that is what we mean by reverse causation. That is what people have argued here. Meaning, people expect higher level of income, and so they demand more money because of that. And therefore, that increase in money demand is then matched by an increase in money supply because the central bank sees the higher money demand and matches it. So it's the higher expected output, according to this argument, that causes the increase in money supply beforehand. Just like the quiz today caused you to study yesterday. In the same logic. Okay? But this does not mean that money is not neutral. In the sense that the increase in money supply is not causing an increase in output. So it's still neutral. However, because people were expecting higher output, they increased their money, so there is an increase in money supply. And why would people, why would there be increase in money demand if you are expecting a higher output? On the firm side, if you are expecting higher sales, then you want to have more money for the transactions you will face. to pay workers, to pay for materials, etc. So, in order for the equilibrium in the money market to remain, given the increase in money demand, the central bank has to respond with an equal increase in money supply. If not, what would happen? When money demand increases, because of an external shock, like the increase in expected output, future output, not current output. Current output is not an external shock. It is an endogenous shock. But future expected output is an exogenous shock. So an increase in expected future output is an exogenous shock. That creates an increase in money demand. What happens then? If the central bank does not match the increase in money demand with money supply? Why does it say here that per price level would decline? What is the mechanism? What happens when money demand increases? The LM curve shifts. When money demand increases, very quickly, money supply, this is money demand, money supply, money supply, money demand, R. Okay? When money demand increases, okay, now first of all, this is Y and this is R. So at this original money demand, we have some LM curve right here. When money demand increases from MD1 to MD2, then we have a higher equilibrium interest rate at the same level of income. That's the crucial part. At the same level of income, we have higher level of interest rate, so we are on a different LM curve, which has shifted to the left. So once that happens, if nothing is done, output would drop below full employment. That would drive down prices.
So why would output go, isn't the output same at the same level of income?
IS, LM, you are here, suppose this is full employment, now LM shifts, so you go here, output has gone down, so this is below full employment.
Wasn't the LM shift maintaining the income level?
That here, yes, here, that means that at each output level, the equilibrium interest rate is higher. Then as a result of this shift, after we have this shift, then the new equilibrium, also including interaction with the IS, with the goods market, then the new equilibrium would be at a lower level of output. And so prices will fall. Prices would fall. So real money supply would go up and restore the equality with higher money demand. Okay? So to prevent this from happening and to keep that equality in the money market, the central bank increases money supply. Right? When money demand increases, if the central bank increases money supply, what happens here? There is no change in interest rate, there is no change in output, so there is no shift in the LM curve. The LM curve remains where it is. Okay? So, due to this mechanism, you would observe leading and pro-cyclical money supply, even if money is neutral. Right? So, however, economists, famous economists like Friedman and Schwartz, have documented that there are monetary changes which have nothing to do with future expected income. Like, for example, gold discoveries. You know, in the past, at least nowadays, with all this Bitcoin and virtual money and all that, there isn't much linkage between money and gold. But in the past, money and gold were very connected. So, if you have a new discovery of a gold, mine, then you have an increase in money supply. This had nothing to do with higher expected output. Yet, even in those cases, you would see higher output after the increase in money supply. So then reverse causation could not explain it, right? Because we knew that the increase in money supply was not due to an expectation of higher output. So that reverse causation argument was failing there, okay? So that is not an entirely convincing argument. So another more rigorous argument is known as the misperception theory. Now, in order for us to have non-neutral money supply, what we really need is, why is money neutral in the long run? Under all theories, and even in the short run under classical theory. If we put, Y here and P here, we have aggregate demand. What makes money neutral? It's the fact that aggregate supply is vertical, right? So even when money increases, which shifts this line from 1 to 82, then we only have a change in prices. We do not have a change in output, which remains at Y bar. That's why money is neutral, right? But that's due to the perfect flexibility of prices. Now, in order to, since we see that we observe there is non-neutrality of money, to represent it on a graph, what do we need? We need an aggregate supply curve that is not vertical. Okay, we need an aggregate supply which is upward sloping. If the aggregate supply is upward sloping, then you can see that you will have some increase in output. So money will not be neutral. Now, how can we generate an upward sloping supply curve in the context of classical theory, where all markets clear, etc., etc.? The argument is an argument about misperceptions. So, this is the equation for the upward sloping supply curve. It says that actual output is equal to the full employment level of output, the long-term output, plus a fraction of the difference between the actual price level and the expected price level. So this misperception theory is based on a misperception about the actual price level. So people know the expected, they have an expectation, and if that expectation does not match the true, correct price level, then the upward sloping, then the AS curve will be upward sloping. So first of all, I show you, I thought the graph would be coming, but let's see how this argument would work. So, again, we assume that all markets clear, wages and prices are perfectly flexible. But one crucial assumption we make is that suppliers do not know exactly what the overall price level is. They don't know P. They just have an expectation PE, which may be true or not. You know, if I ask you all, you may not know what exactly the inflation rate is today or this period. You may have some idea, but you may not probably exactly know it. So, oops. The same thing happens in this case. Now, suppose we are talking about producers, right? We are looking at the supply side of the economy. So when producers take their decision on how much to supply, they will be basing that decision on the relative price level, which is what they are earning given the overall price level. It's P over PE. Okay, so in case, for example, we consider differences between P and PE, then if they have a wrong understanding of PE, if P is, say, higher than PE, then they will think, so they don't know P, but they know PE, right? So let me go through the argument and then you will see how it works. The example given by Abel Bernanke is about a bakery that makes bread. So the price of bread is the baker's salary. And then that's the nominal salary. The real salary will be the price of bread divided by the general price level, right? That will be the real salary of the baker. So if that real salary goes up, we know from the graph in the labor market, if the wage is going up, the real wage, what happens to supply? It's upward sloping, right? If the wage goes up, labor supply goes up, right? So, however, the baker does not know the overall price level. He or she only knows the expected price level. So, suppose that the expectation is correct. Then he will observe a change in the price of bread, say 5%. And then he has an expectation that the general price level also increases by 5%. So its real wage will not change. So he will not change his production. But suppose, for example, that he sees an increase of 5%, but the actual increase is 8%. So he will feel like his real wage would be going up, and he would increase the production, right? So if he increases that production, and if everybody does the same, because nobody knows the real overall price level, but they all act in terms of expectations, then you will end up with higher level of output due to this difference between P and PE. Right? So if the true price level is higher than the expectation, so if you observe, say, if you expect 5%, but the true increase is 8%, then you will increase your production because you will think that your real wage has gone up. Okay? So, for this reason, and this will be the equation that will represent the whole thing. So this is at macro level. It takes into account all producers. But each single producer acts in the same way. They look at what they are selling. If that increased, they will be led into thinking that they are earning more. so they will produce more, even if the general price level actually did not change. So, for that reason, we have an increase in output, as represented here. We have higher output, output, which is a function of the long-term output, plus the difference between the actual and the expected. So if that difference is positive, that means we are increasing our production more than white bar. We are producing higher than white bar. If the difference is negative, then we will be producing less than white bar. So that's exactly the upward sloping line. And the line will be passing through white bar exactly where P is equal to PE. You can see that here. Right? When P is equal to PE, this term is 0, so Y is exactly equal to white bar. Right? So this will be your short-run aggregate supply. Markets are still clearing, prices are still flexible. However, there is this misperception. The true price is not the same as your expected price. So you see an increase in what you are selling, and you think you are richer, so you produce more. However, that wasn't the case. It's a misperception. Is this argument clear? Or you need me to remake it? Remake? Okay. So, let me go back a couple of slides. Here. Okay, so let's take this example of a bakery. Okay, so the baker sells bread. So that price of bread is his nominal wage. Okay, that's what he observes. Now, the baker decides how much to produce based on his real wage. How does he determine the real wage? In general, you should divide by the price level. Except that the baker does not know the true price level. He only has an expectation about it. So he uses that expectation. Okay? So, suppose the price of bread increases by 5%. Okay? So, this one is trivial. If inflation is 5% and there is no change, it's P is equal to PE. Okay? But suppose that the general price level is, he expects 5%, but the bread rises by 8%. Okay? So he thinks bread rose 8%, divided by 5%, it's gone up. His real wage is gone up. So let me increase production. Okay? But that is a misperception, because that misperception was caused by his thinking that the general price level had gone up by 5%. However, the general price level is gone up by 8%. So it's not richer. If he knew that the price of bread increase was a simple reflection of the general price level increase, he would be not increasing his production. The reason why he does increase his production is because he sees the increase in the price of bread, but he does not see the increase in all other merchandise. So he doesn't know that he's not actually becoming richer. That happens quite frequently, right? We all face this. We get a higher salary, we work out all happy, but then if you take a look at it, we may even be poorer, in fact, because actually what we get, we are spending on things, and those things have increased even more than what we got. So it happens to all of us all the time. So that's the argument here. And because of that misperception, we have the upward sloping curve. Is that clearer now? Okay. So now, given the upward aggregate supply, if you go back to examining the increase in money supply, there can be two types of increase. One which is unanticipated, unexpected. It's a surprise. Surprise increase in money supply. So in that case, AD shifts. So we go from here to here. Right? And because of the misperception, we have an increase in output. Then, as people adjust their information, eventually they will, right? Eventually we all realize that when we go and buy a cup of coffee, instead of the old 80 rupees, we are now paying 500 rupees. I'm not joking, it's, go around and see. So, it's, eventually we all see this. So we will adjust the expectations, yes?
So basically, when AD1 shifts to AD2, price goes from P1 to P3, right?
To P2. Because of the, if we are on the up, we are on this.
And because the supplier has...
Because of that misperception,
then
the supply has increased.
The SRAS1 shifts to...
Not yet.
Achha,
Not yet. So, before any change in expectations, before we realize that the cup of coffee is no longer 80 but it's 500, we are here. Producers happily increased production, thinking that they were richer, and price would have increased to P2. Then, in a second step, people adjust their expectations. So once they do, this supply curve will have to shift because the position will pass through, PE, where the aggregate supply crosses the long run aggregate supply is at PE. So eventually, here, given the new expected price, when expectation change, then the curve will have to go up when you adjust. So it will move back here, and then you will be back at the full employment level. Now, this is if it is unanticipated. However, when it is anticipated, then all that happens in the blink of an eye, because we know that there would be an increase in prices. If we know that there is an increase in money supply, and that money supply generates the increase in prices, then when we see an increase in money supply, then we expect the increase in prices. So therefore, we will not be fooled into going here, but this line, the expectations would immediately change. So we will move from E to H right away. There will be no time spent in that position there. So price will never become P2. It will go straight from P1 to P3. This is when it is anticipated. Because in this case, there will be no misperceptions. The whole story there is caused by misperceptions. It's different from the previous story we saw that was caused by price rigidities, where price was not changing. Suppliers were willing to increase their production at the same price level. So that was another story. Now here, suppliers are producing more because of the misperception. That's the story here. Okay? So, now we can tell the same story with the algebra that I know you love so much. So, we have the equation for the aggregate demand curve. We have already seen this equation. Should not be new. Y as a function of prices. Okay? Now, the aggregate supply curve is this equation we have just seen. So, what we are looking here, we want to find the equilibrium price where the two lines cross. So how do we find the equilibrium price? from the aggregate demand equation and the aggregate supply. Equate the right-hand sides of these two equations, right? Here it is, the right-hand sides equated, okay? And now we have to make a bit of algebraic manipulation here. So first we multiply by that denominator, which is here, beta S plus beta Lm, multiply through by that, okay? Here, we get it everywhere, except where it was there already. Then we multiply by the price level, which is also in the denominator. You see here, the price level is in the denominator, so we multiply by that, okay? So that's what we do here. And then, so you can see here, you have a quadratic equation in P. We have a term in P squared with a coefficient here, which we call A2, is this coefficient here. A term in P, we call A1, and a term without P, which we call A0. So that's a quadratic equation in P. You remember from your high school how to solve the quadratic equation with the quadratic formula, right? So we use that. And so P will be equal to the equilibrium P, that P here will be equal to this, okay? Where all the A2, A1, and A0 are as I showed you before. Now, so if we are asking a question, what happens to the equilibrium P as we increase money supply? What is the answer to that? You have to go back and see where is money supply appearing. It's here, right? This is money supply. So it's in this coefficient A0, right? So look at here. P is a positive function of A0, right? There is a plus sign here. So if money supply increases, A0 increases, and P increases. Right? Is that a surprise? We know that if money supply increases, the AD equation shifts, and therefore we go from here to here. So you see we have a higher P. The equilibrium P is higher. How do we find, after finding the equilibrium P, how do we find the equilibrium output?
Because if that's positive, it means one of the A's should be negative.
No, this is minus, but this is plus.
Within the bracket, it's B square minus 4AC.
Yes, but here it's with minus. So two minuses become plus. Right? So if you make it, you have the 3, A2, A1, A0. If you write it, you see that, because there you have, actually it's not A0, it's minus A0. That's the point. So that is what makes it plus. In the formula you have in mind is minus 4AC, but here we have minus C. Right? Okay. So in order to get the equilibrium output, what do we need to do from here? How do we get the equilibrium output? Once we have our equilibrium price, how do we get the equilibrium output? This quantity here. Or even this one here. How do we get it? We have to go back to this equation, right? And replace P with the value we computed. And then we have our Y. It's like just like in any other system of equations in algebra. Once you solve for one variable, then to find the other variable, you use the variable you computed, put back, and find the other. So that's how you find y. Okay? Now, if y is at the full employment level, what happens? Then we are back to the situation where P is equal to PE, and therefore, in that equation, y is equal to y bar. So that's that. Y in that case is equal to y bar. Okay? It's just like the case we saw before. Any question? Is this algebra clear? Yes? The way we get it? Okay. I forgot to flip this one, so this I correct the other ones. Anyway, so the usual black sea scene facing you, which tells you that it's done, it's over for today. So we'll meet again on Wednesday, and I don't know if you all know, I reserved for our classes, in addition to this place, the lab across. So if we want, we can have class over there as well, including those Kahoot lively quiz we can have over there. So we'll no longer have the issue of wireless, no wireless. We'll have a desktop computers and we'll be able to do that there.
Marusi.